this video, we will discuss how to use Python SymPy to solve basic, by which I mean one variable, algebra equations. We'll say a few quick words as to the theory behind solving single variable equations by hand, but won't dwell on it. Then I'll show you how to initialize a SymPy session, representing an equation using this EQ class, note the capital E in EQ, and then solving your equation in a couple of ways, one with the solve function, and then another one with the solveset function, both of which we will import when we import everything in SymPy, when we initialize the SymPy session. And if some of that didn't make sense, don't worry, we'll explain everything. So let's get to it. And the first thing that you're going to need to do is know a little bit about the theory of how to solve a single variable equation, just kind of the basic algebra. So apologies for this old hat, but in essence, if you have something like x plus 2 equals 3, you would just want to isolate the variable onto one side of the equation and the number on the other side. So in this example, which is a simple example, we would just subtract 2 from both sides, x plus 2 equals 3, minus 2 on both sides, and you end up with x equals 1. And then, of course, you can check that that's correct by just plugging in the 1 for the x. So you would have 1 plus 2, of course, equals 3. And in this simple example, you could just eyeball it and say, well, I know 1 plus 2 equals 3, but of course, there are much more complex examples where you would have to do a lot more by hand in order to solve it, and it gets even more complicated if you have like an x squared or an x cubed in the mix. So definitely good that we can solve this just very, very automatically and quickly using Python, and specifically using the SymPy library. That does not come with Python, you need to install it. So that's the next thing we're going to show you, is just really quickly, if you haven't installed SymPy, you will need to do that, and you can just do that very quickly by going to your command line. I'm just showing you in the terminal that comes with PyCharm. You see I just switched to terminal here, and you can just type pip, P-I-P, space install, space SymPy, and that's S-Y-M-P-Y. And if you hit enter, it's going to tell me I already have it, requirement already satisfied. But if you don't have SymPy, that might be one way to get it. You can also check out the link in the description to the SymPy website with more ways to download. So with that, now that we have SymPy installed on our machine, we're going to want to import it and then initiate a session. So to import SymPy, we're going to type import SymPy, and this alone would do it, but we're actually going to give it a nickname because SymPy is a little long to be typing SymPy, SymPy, SymPy over and over, so we're going to import it as SP. And all this is saying is, hey, from now on, whenever I type SP, I'm going to be referring to SymPy, but otherwise it's just importing the whole thing. So you hit enter, and now you've imported SymPy, and that's all there is to it. So next, we're going to want to do what's called initializing a session in SymPy, and that's really nice for something like solving equations. If you want to do one after the other, this initializing the session is going to make your life a lot easier, because it's going to automatically do a lot of the stuff that you would need to do up top. So to do that, you just type sp, which remember is what we're calling SymPy, dot init underscore session, and you see PyCharm's already guessing what I want to do, and it's correct. So sp.init session with these parentheses afterwards, okay, because it's a function. And you hit enter, and what just happened? Well, it did a lot. So as you can see, it executed some commands, and those commands include from SymPy import all, which is great because we are going to be using a couple of things from SymPy, including EQ, solve, solveset, so we won't need to import those specifically. It's imported everything. It's set some symbols, x, y, z, t. That's great because we can use these in our equations. We can solve for x, we can solve for t. Okay, so this is really helpful. And it also did init printing, which gives you the best printer possible in the IDE that you're using. So in some of our other videos, we went to cocalc.com, for example, which, you know, is a Jupyter notebook and has very beautiful printing. In this video, we'll just be going from PyCharm, which doesn't have any special like LaTeX printing or anything to write home about, but it'll get the job done. Okay, and by printing, I just mean how it displays its output. All right, so now that we have SymPy imported as SP and we've initialized our session, we are off to the races. and we are ready to solve an equation. So one important note about SymPy. Usually when we type some operation into Python, like the square root of 2, for example, it'll convert it into some decimal value, but the beautiful thing about SymPy and why it'll work so well for solving equations, which we're going to do soon, is it'll actually keep it in kind of a symbolic form. So if you do sqrt2, right, and that sqrt, that's not the math.square root that you might see from the math module, that's actually SymPy's square root, which we imported when we imported everything from SymPy earlier, which there it is, import all, and then that's included that sqrt. So if we do sqrt2, it's going to just keep it as a symbol. See that radical symbol, radical 2, and that's so that's really nice. And the same is true for equations. If we have an equation, then it will keep that equation in kind of a symbolic form. So let's make a variable and store an equation inside that variable that we can solve for later. Okay, so let's call our variable eqn. And then we can put an equal sign, and that's, you know, for those of you who are just starting with Python, this equal sign is just our way of storing a variable. It is not equals in terms of like x plus 1 equals 3 or something. It's equal just means storing something inside this variable. The variable is called eqn. And what are we going to store? We're going to store an equation. And so to write an equation in SymPy, you type a capital E, then a lowercase q, and then parentheses. And then inside these parentheses, you can write your equation. And here's how your equation will be formatted inside the parentheses. Let's do x plus 9 equals 8. So to do that, we will write what's on the left side of the equal sign first. In our example, it was x plus 9 equals 8, so we'll first write x plus 9. Then we want this to equal 8. You can't use an equal sign here. The equal sign is taken, it's a variable assignment, and even in SymPy, where everything is symbolic, the equal sign is still just variable assignment. It is not going to work, and so if you do x plus 9 equal sign 8, it's not going to work for you. Instead, you write a comma, and then, and there can be a space if you want, there doesn't have to be, and then you write what's on the other side of your equation, in this case 8. And so this is x plus 9 equals 8, okay? So, and we've stored it. And so eqn is our variable, equals the equation x plus 9 equals 8. If we wanted to print it, okay, so say you just did print eqn, it's going to just print it like this. But if you do eqn, it will actually show you x plus 9 equals 8 as an equation, okay? So, you know, because we're in the console here. So it'll show you x plus 9 equals 8 as your output. So that's great. So we have our equation, x plus 9 equals 8, stored inside the variable eqn. How do we solve it? Well, there's a couple of ways. The first one I'm going to show you is a function in SymPy called, appropriately enough, solve. And that's solve with parentheses. And you don't have to write anything before this. We've imported it, as mentioned, when we imported all from SymPy. So you have solve, and then inside the parentheses, you can just put your equation, which you don't need to write out by hand because you stored it in a variable. So solve eqn, our variable eqn, in other words, solve this equation, x plus 9 equals 8. And when we hit enter, it gives you -1. And is that correct? Well, -1 plus 9 is the same as saying 9 minus 1, so to speak. In other words, 8. So we plugged it in, the -1 into x, and it all checks out. We solved our equation. 2 notes. First, you don't, strictly speaking, need to use this variable eqn. You could do, it's a little more cumbersome, but you could certainly do solve with the parentheses, inside the parentheses, the capital EQ, and then inside those parentheses, you can put in the equation you wanted to solve. So x plus 9 comma 8, for example, and you get the same result. So that's perfectly acceptable. And that's fine. And then another second note is this process will also work okay if you have an x on both sides of your equation, and if you have more than one potential answer for x. It'll the Python, your computer can handle it all. It won't have any problem with that. So, for example, let's just keep using the variable eqn. If we made the variable eqn eq, right, for equation 8 times x squared, comma 7 times x plus 51. So if we do this, what is this? Okay, so eq, so it's an equation. On the left side of the equals sign, we have 8 times x squared. So in other words, 8x squared. But notice you do need to have you need to manually type in this star for multiplication here and here. If you were writing this by hand, you would write this as 7x plus 51, but you actually need the 7 times x plus 51 for this to work. Also, notice that in Python, raising to a power is star star. It's not a caret like you might see in some other languages like Julia. What you have is x star star 2, x to the power of 2. Okay, so eqn equals the equation 8x squared equals 7x plus 51. And notice using the equals here to do a variable assignment, not an equal sign here, it's rather a comma when we have the equation, and we'll store it. And then if we were to solve it, solve eqn, okay, no sweat at all, negative 17/8, comma 3. Notice we have two different solutions here, which is accurate because we have this x squared, and so there's going to be two possible answers for the equation. And if that doesn't make sense, do take a look at my videos on roots and on exponents. I have a video on both of those subjects, which go into why that would be in a little more detail. And did this work? Well, we can try it by plugging it in. Let's check it by making a variable called a variable called var negative 17/8. So now we have our variable, and it's going to just equal one of our solutions here, negative 17/8. And let's just plug it into what this equation was for every time we had x here. We can just instead plug in our variable. So if it was 8 times variable to the power of 2, you get this 36.125. And then on the other side, we had 7x plus 51. So 7 times variable plus 51, is it going to equal 36.125? And it does. Okay, so that's great. The 3 will work here too. 8 times 3 squared is just 8 times 9, which is 72. And then 7 times 3 is 21, and 21 plus 51 is also going to get you 72. So it actually works very well. It's on both sides, as it should, because the computer is a lot better at doing this than a human being, and it came up with these solutions in the blink of an eye. So that's perfect. Okay. 2 more notes about this solve function. 1, if you want to use multiple symbols, kind of a multivariable equation, you can. That's not going to be the thrust of this tutorial because it can get very complicated, but recall we made a bunch of symbols in our, when we initialize session, we have x, y, z, t. Okay, so those are all in play. So if we wanted to make our variable eqn equal eq plus 1 comma x, okay, and then all we have to do, so now we have this equation with a t and an x. When we do solve of eqn, you just do one more thing. You do comma, and then whichever variable you want to solve for. So if you're solving for t, you will see that the answer is x minus 1. That makes sense. T plus 1 equals x. So if you subtract 1 from both sides, minus 1, you'd end up with t equals x minus 1. And of course, if you do solve eqn x, then you'll be solving for x instead of solving for t. And you see that it's t plus 1, which of course it is because t plus 1 equals x. You actually already had it just like that. So that's how you would do it if you're using a couple of different variables. Just don't forget when you do solve to specify the variable you want. If you don't, it will try to help you. As you can see, it'll say, hey, yeah, t is x minus 1, which is true, but you want to just make sure that you're solving for it. So t plus 1 equals x minus 1 minus 1, so t equals x minus 1, as we saw here, and here it's basically telling you the same thing. Okay. But do if you're looking for something in particular, specify the variable by doing comma and then whichever of the symbols you're solving for, whichever variable in the mathematical sense of variable you're solving for. Okay. Second note on solve: if you don't specify a value on the other side of your equation, the equation will assume that it equals 0. What do I mean by that? Well, if you do EQ of just, x plus 13, it's going to be angry with me, but it will assume that this means x plus 13 equals 0, and it will be angry with me. So yeah, as you can see, I got a lot of angry text here, but x plus 13, equation of x plus 13 equals 0. It does understand that, and if I do solve of that equation, whoops, well, I didn't I didn't set it to be the equation, but if I do set the equation now to be x plus 13, and if I solve that, it'll do it, negative 13, it'll solve it, it'll all work. But what's all this angry text? Why did I get so much, why did I get so much of this? Well, what happened is in, as you can see, it's in SymPy 1.5, the previous version, it's saying, hey, that's how we used to do it, basically, but don't do this anymore. Instead, use your expression comma 0, and it gives you a link for further explanation. If you click this link, it'll explain that it was confusing to have the EQ expression with the default being equal to 0. It was confusing to users, and so they made the decision in SymPy to instead have you do the expression comma 0. So if I do EQ x plus 13 comma 0, which remember is the same thing I did up here, it's going to also give me x plus 13 equals 0, but this time nice and clean. It's my computer's happy, Python's happy, SymPy's happy, no angry text. Okay, so that would be the recommended approach. The best practice is to do EQ expression comma 0, even if it might be faster just to do EQ expression. And then a similar thing is true for solve, though with solve you're not going to get the angry text. But if you do solve of x plus 13 and you don't specify an equation, you could certainly do solve parentheses EQ parentheses x plus 13 and it'll work, but you don't need to. You can just do solve x plus 13 and it's going to read it as solve x plus 13 equals 0 without having to specify this EQ. So, and you see you get negative 13, negative 13 plus 13 equals 0, and that's what it solved. Okay. So that's actually very handy, because often when you're doing these kind of, like x squared plus 3x equals 0 or something, right? Like, then it'll solve it for you, and that might be a lot faster. Depends on what you're doing. Okay. So let's move on from solve, and let's move on to the other one, solve set. Okay, and we'll just show you that it's quite similar. So one more way that you can solve equations with SymPy instead of using solve is to use solve set. And again, we've imported everything from SymPy, so we have solve set already from when we initialized our session, so you just need to write solve set. And that will work just fine with what we had done before with equations. So if you do solve set of EQ of 9 times x plus 3 comma 12, and so what's this? This is the equation 9 times x plus 3 equals 12, and then solve it. And it'll give you your solutions, which in this case is only one solution, and it's a 1. Okay, so solve set is really great if you're doing more complicated equations, and in fact the SymPy documentation, if you look at that, the link to which will be in the description, does recommend using solve set over solve in most cases. For these kinds of very basic single variable algebra equations, honestly, it's both are going to work just fine. So just kind of two different ways of reaching your answers. You can also, of course, make your equation a variable if you're, I'm just going to copy paste it. But if this is your equation, you know, and then you've stored inside the variable, if you do solve set of the variable equation, EQN, it'll give you the same result, works just fine. And if you have something more complicated, you know, with more than one solution, it'll list them both out. So this time, let's make it, you know, like squared, you know, so that we get a couple of things, and then just, you know, now it has two different things. -1 and 1 are both viable correct solutions to this equation. And so, and if, you know, you're still in school and doing your math homework, for example, you're going to want to give both of the correct equations, or else, you know, you'll lose points. And you'll also want to show your work, so you can't just cheat by using Python. But you know, you can certainly use this as a double check to check your work. And you know, if you're getting the wrong thing when you do it by hand, you might want to take another look and see either you typed it in wrong in Python, or maybe you made a mistake when you're doing it by hand. Okay, and a couple other things. One other thing with solveset, if you want to do those multivariable, you know, you use more than one symbol, like an x and a t, you can do it just like you did it before. All you have to do is specify again which variable you're looking for inside the solveset, inside the parentheses. So what you do is you do solveset. So actually, well, let's make a new equation. If your equation is EQ of x plus 1 comma t, you know, -9 or something. So this is x plus 1 equals t minus 9. Okay, and now we've stored that. And you can do solveset EQN, so that's the first thing, or you could have typed out your equation here all before this first comma. And then for the second thing that you write, your second argument after the comma is whichever variable you're solving for. So if you're solving for x, it'll do it. It'll tell you, yeah, x equals t minus 10. If you were doing solving for t, you would just put the equation, comma, t, and then solve for t, and it's x plus 10 in this instance. Okay, and so that all works. That works just fine as well. Okay. And also, you know, this can be good for if you're doing something where x equals 0. You don't need the EQ. It's just like solve in that respect. So this can be good for something like if you're doing like solve set of x squared minus 4. Notice I didn't put in the EQ. I didn't make this a variable. I'm straight up doing solve set x squared minus 4. And what's this really asking? It's asking solve the equation x squared minus 4 equals 0. But you don't need to put the equals 0. It's assumed. And it'll do it. -2, 2. Both solutions here. As you can see, -2 squared is 4. 4 minus 4 is 0. 2 squared is also, of course, 4. And 4 minus 4 is 0. Those are both solutions to this equation. And that's really the theory behind it. If you wanted to do this in like a Jupyter notebook or in a more mathy environment, you can go to like the cocalc.com that you might have seen in other videos, or there's some other more specialized environments out there, certainly. And so, you know, and also those will have like pre-written snippets of code that you can just plug in. It'll do a lot of the work for you, though with this one it's not too bad because you can just initialize the session with the init session as we saw up above. And so that's about it. But I do want to thank you for watching. You know, now let me know in the comments how this worked for you. And I appreciate your time looking at this video. Thank you. Take care.